right, welcome to this video where we're going to learn about Hess's laws, which happens to be one of my favorite types of problems. I really do enjoy them. And so what Hess's law is sometimes it is impossible or impractical to measure the change in enthalpy of a reaction. And so there's a lot of ways that we can measure the change in enthalpy of a reaction. We can perform the reaction in a calorimeter, we can measure how much heat is given off, and then we can determine what the change in enthalpy is. But there's a lot of chemical reactions that it's not practical to do it in that way because they have to maybe happen under a certain condition, or there's not a very efficient way of measuring the amount of heat absorbed or given off. And so what we can do is use Hess's law to calculate the change in enthalpy of a chemical reaction. And this is essentially what Hess's law says. It says that if you can add two or more different chemical reactions together to make the chemical reaction that you are trying to find the delta H for, then the sums of those other chemical reactions, delta H, will equal the delta H of the reaction you're trying to find. And so essentially what we do is we take other chemical reactions that we do know the delta H's of, we manipulate them in such a way to where when we add them together, it makes the chemical equation that we're trying to find the delta H for. And then we just need to add their delta H's together. And so there's a couple rules that we need to follow. First off, if you reverse a chemical reaction, what you do is you change the sign of the delta H. So notice how here we have A plus B yielding C is a positive 60 kilojoules of energy. Well, if you flip that, notice how it becomes a negative 60 kilojoules of energy. And so we can flip a chemical reaction. We'll talk about why we want to do that later. But when you do that, it makes it a negative kilojoules of energy. We can also multiply a reaction by a certain coefficient, and so we can multiply it by 2 or 3 or 4 or whatever. But if we do multiply it, we also multiply the delta H. So notice how we have A plus B yielding C is 60 kilojoules of energy. If we were to multiply it all by 2, which there are reasons why we would do that, we would end up with 120 kilojoules of energy because we multiply that by 2 as well. And then we can use rules 1 and 2 together. And so, for example, we have A plus B yielding C is 60 kilojoules of energy. Notice that if we flip it, it becomes a negative, and we multiplied it by 3, so we multiplied the delta H by 3 as well. So we flipped it and multiplied it by 3, so we can do that as well. And so when manipulating chemical equations, a compound or element must appear on the reactant side of one reaction and the product side of another to cancel out. And so let's say that we have two different chemical equations and we have carbon dioxide in the reactant of one and carbon dioxide in the product of the second one. What ends up happening is when we add those equations together, those will cancel out. So if they're on opposite sides, they will cancel out. Now, if they're on the same side, they add together. So if we have carbon dioxide in the reactant of one and let's say 2 carbon dioxide in the reactant of another, that'll, when we add it together, give us 3 carbon dioxide. And so here is an example of Hess's law. And so I will actually go through and do practice problems and through the guided practice problems. But what I wanted you to notice is, notice how, first off, let's look at the waters, all right? Actually, let's look at the carbon dioxide. Notice how the carbon dioxide in the very first equation is crossed out because look at the third equation. It's on the reactant side. So it's on the reactant side in the third equation. It's on the product side in the first equation. Because they're on opposite sides, they cancel out. Now, also notice how the water on the second one and the water on the third one, they actually add together to make 2 waters total on the reactant side, but that cancels out with the 2 waters on the product side in the first one. And so notice how all these 3 chemical reactions, they do add together. Once you are able to cross out everything that cancels out, they do add together to make that bottom chemical equation there. And so all you would need to do is add those delta H's together, and that gives you the delta H of that bottom chemical reaction. So these are really fun problems. They're like, it's like a puzzle. And so you flip equations around, you multiply them, do whatever you need to do to make it to where it all cancels out and adds together to make what you're trying to make, and then you just add the delta H's together. And it's that simple. And so go ahead and watch the guided practice problems, and you guys have a great day.